Morning everyone, my name is Lokesh, son of Komarapuru, from the class RY31. My matric card number is 211291003. Today, I would like to present on management and evaluation for the transmission line project, mini project, from the course EMK31303. I am from group number 14. Let me introduce my group mates. The first of all is Namanithan Ananalaki Tureraj, and the second one is Dinesh Raj Ananalaki Govindaraju, and the fourth person is Narayan Fatiha Binti Nur Asman. Next slide is the introduction. Okay. The introduction is the case study for construction of 275 kilowatt overhead line with 1000 megawatt capacity for Rawang to Kuala Lumpur. This transmission line connects Rawang to Kuala Lumpur. The project emphasizes the significance of maintaining stable condition, efficiency, and reliability over the life cycle of transmission line, as well as assessing the infrastructure's reliability over long distance. The scope uses efficient resource management, adherence to regulatory standard, and use of advanced technologies. The aim of the project is to provide detailed insights into the various stages of infrastructure developed in West Bengal. Additionally, the broader impact of the project addresses environmental considerations and technological advancement to ensure long-term sustainability. So these are the sub-points for challenge faced by the overhead lines constructions in Peninsular Malaysia. First of all is the complex specifications. The image outlines the key challenge faced in the construction of overhead line transmission line in Peninsular Malaysia. This keeping up with the technological advancement is crucial to enhance transmission line performance by implementing the latest market technologies. Environmental impact is another significant challenge, necessitating strategies to understand and mitigate the adverse effects through sustainable practices. Effective risk management is essential to identify potential risk and develop comprehensive plans to minimize them. Efficiency resource management ensures optimal use of power and resources to prevent wastage and ensure timely project. Involves adhering to all relevant laws, regulations, and standards required for constructing transmission lines based on permits and standards required for constructing transmission lines by higher authorities. Next slide is the literature review. Let us take a closest view of the literature review. The literature review is about the construction of overhead line transmission in Peninsular Malaysia, highlights several key areas critical to project's success. First of all is the technological advancement. The use of advanced systems for real-time monitoring and automation is emphasized. This involves deploying sophisticated technologies to continue, monitor and control the transmission lines, ensuring high reliability and efficiency. Moving on to the next point, environmental consideration. Sustainable practices are vital to minimize environmental damage during the construction and operation of transmission. This includes adopting methods that reduce ecological footprint and implementing strategies to ensure that projects remain sustainable over lifespan. Third point is the importance of energy transmission. Energy transmission is crucial for sustainable development, underpinning economical growth and development. Efficient and reliable energy transmission systems are essential for the effective function of various sectors. Moving on to the next point, stakeholder engagement, which is engaging stakeholders in the planning and execution phases, is essential to address the concerns and ensure their needs are met. This involves involving local communities, government agencies, and other relevant parties in decision-making process. Moving on to the next slide is the objectives of the project. This project aims to achieve several comprehensive objectives. First, it seeks to provide in-depth insights in the planning and construction and evaluation of electric transmission line, enhancing understanding of entire construction process. This involves studying the impact of environmental factors and technological. It focuses on constructing a 275 overhead line with a 1000 megawatt capacity to meet growing demands of Kuala Lumpur, supporting both the metropolitan area and industrial growth. Additionally, safety. Finally, project emphasizes the principle of reliable, cost-effective, and environmentally responsible energy infrastructure management, ensuring that the transmission lines are not meet current demand but also contribute to long-term sustainability and reliability of energy. That's all from me. I will pass to the next teammate. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Roy Fatihah binti Osman. Matrix ID is 211291021. Okay, so let's go through for my part, which is 4.3 project planning and scheduling. Okay. So let's refer to table 4.2, which is the sequence of activity for the transmission line project. So for this table was given as for the task complete in this project. Okay, so the project schedule utilize the activity on arrow AOA approach. AOA visually represent task sequencing with arrows for activities and nodes for milestone. It links activities with arrows to show workflow and dependencies. AOA simplifies project timetable and enhance management effectiveness. It clearly conveys activity details by emphasizing interdependencies. This method promotes efficient collaboration and ensures timely project completion. Okay, so next for 4.3.1 part, which is calculation of expected time TE for activities using the AOA method. Okay. Let's refer to table 4.3. This is the chronological sequencing and time estimates of project activities. Okay, so the table outlines the sequence and timing of project activities, including the start and end events. Each activity is preceded by its predecessors and providing a clear understanding of task dependencies. Time estimate for each activity include optimistic TO, TM and TP durations. The expected time TE for each activity is calculated using the formula TE is equal to TO plus 4TM plus TP over 6. Okay, so this table serves as a framework for project scheduling and management, facilitating efficient allocation of resource and time. And it helps in identifying critical path activities and managing project timelines effectively. Okay, so next we go to the 4.3.1. This is the calculation of expected time TE for activities using AOA method. Okay, so let's see for the activity A and TP. This calculation was made by using the formula just now. TO plus 4TM plus TP over 6. Okay, so this is the value for TE that we include in the table 4.3. Okay, so next activity on arrow AOA. Okay, from this part, this is the AOA for project network diagram. Okay, we can see from 1 to 2, we can see the part of A. There are number of 7, 2 and 9, and at the below with the green color there are 4. Okay, how we get this? So that is from by referring the table 4.3, which is for number 7 to 9 is the value of TO, TP and TM, and with the green one, which is 4, this is the value for TA. Okay, what about 1 to 2? 1 to 2, the numbers are from 1 to 2 in the scale. Okay, so okay, so for this part, the number 1 to 2, this is we made it by referring table 4.2, which is, it says that the interrelationships like a B is dependent from A. Okay, so this is, we made it into the project network diagram, and this is how we complete the task for project network diagram. So that's all for my part, and thank you.
Hi, my name is Nawanida Analaki Raj. My matrix ID is 211291020. Today we are going to discuss about critical path analysis and project completion time. The critical path method, or CPM, is a vital project management tool used to determine the sequence of crucial steps needed to complete a project efficiently. On this slide, we see the visual representation of our project activities using the activity on node, which is AON approach. This approach helps us clearly identify task relationships and dependencies which are crucial for effective project management. The critical path is the longest sequence of activities that must be completed on time for the entire project to finish on schedule. In our project, the critical path is A, C, E, G, L, M, and P with a total expected time of 75 weeks. Understanding the critical path is essential because any delay in these activities will directly impact the project's completion date. Therefore, monitoring and managing these activities is a top priority. We have also evaluated other paths such as Path 1, A, C, E, G, H, I, and P with a total expected time of 73 weeks, Path 2, A, C, E, G, J, K, and P with an expected time of 72 weeks, and Path 4 with A, D, F, H, I, and P with an expected time of 62 weeks. These paths, while important, do not dictate the project's end date since they are shorter than our critical path. It's important to note that although these shorter paths do not define the project's completion date, they still require effective management to avoid potential delays that could impact the overall timeline indirectly. Effective identification and management of critical path allow project managers to prioritize resources and efforts on the most impactful activities, ensuring timely project delivery. Now let's move on to the next slide, which is the calculation of standard deviation for activities using the AOA method. In this slide, we're going to discuss about the calculating the standard deviation, which helps us to understand the variability and uncertainty in our time estimates. The standard deviation is calculated using the formula sigma equals to TP minus TO over 6. Here TP represents the pessimistic time, which is the worst case scenario, and TO represents the optimistic time, the best case scenario. The division by 6 helps us to determine an average range of estimates. For example, let's consider activity A. With an optimistic time of 3 weeks, a mostly time of 4 weeks, and a pessimistic time of 5 weeks, the standard deviation is calculated as 5 minus 3 divided by 6, which equals to 0.33 weeks. This means the activity duration is expected to deviate by 0.33 weeks. Similarly, activity B has an optimistic time of 7 weeks, a mostly likely time of 9 weeks, and pessimistic time of 17 weeks, resulting in a standard deviation of 17 minus 7 divided by 6, which is equaling to 1.67 weeks. This indicates a more variability and risk compared to activity A. The table on the right summarizes the standard deviation calculation for all activities, highlighting those with higher risk based on their variability. Activities with higher standard deviation needs a closer monitoring and effective management to mitigate risk. By understanding the variability in our time estimates, we can better anticipate potential delays and plan accordingly. This proactive approach helps us in managing uncertainties and maintaining the project schedule. Moreover, identifying activities with high standard deviation allows project managers to allocate additional resources or implement contingency plans to address potential issues, thereby reducing the impact on the overall project timeline. Now let's move on to the third slide, which is the project completion time with confidence interval. Now, in this slide, the cumulative expected time TE for our project is calculated as 75 weeks. However, to ensure that we meet our completion date with a high degree of confidence, we must account for event standard deviation. The event standard deviation is calculated by summing up the variances of all activities on the critical path, then taking up the square root of that sum. For our project, this results in 4.04 weeks. To achieve a 99.85% confidence level, we use the formula schedule date equals to TE plus 2.97, which is derived from the Z value using the table and the value of variance in TE. Substituting our values, we get 75 weeks plus 2.97 times by 4.04 weeks, which equals approximately 87.01 weeks or about 20.02 months. This means that to be 99.85% confident of completing the project on time, we should plan for an overall duration of around 87 weeks. This buffer accounts for uncertainties and helps to ensure the project is completed successfully and on schedule. By incorporating this buffer, we can better manage potential risks and delays, providing assurance to project management and stakeholders that the project will be delivered as promised. This high level of confidence in project completion time is crucial for maintaining stakeholder trust and ensuring that all project objectives are met within the specified time frame. In summary, critical path analysis, standard deviation calculation, and confidence intervals are essential in tools for project management that help in planning, scheduling, and risk management, ultimately leading to a successful and timely completion of projects. Thank you.
Good evening, Doctor. My name is Dinesh Raj Anlaki Govindaraju and my metric number is 211290996. Today I'm going to present about the cost of project. So initially the length of transmission line is 60 kilometers and the distance between each transmission line is 300 meters. So based on the length and the distance between each transmission line, the total number of needed towers are 200 towers. So each tower consists of four basements which needed to dig hole. So each tower has 4 basements. Therefore, there are 800 holes need to be digged. Then amount of soil need to be digged. For LST, each hole is usually 3 to 4 feet wide and 15 to 30 feet deep. For TSPs, require one hole that is up to 8 to 12 feet wide and 40 to 60 feet deep. Type of transmission towers chosen is LST, which is 4 feet wide and 25 feet deep. And in cubic, it's equals to 11.32 meter cube. Now I'm going to present about the crane cost. The total unit of crane we have used in this project is total 2. So each crane cost is 1,200,000 ringgit. So the total cost is 2,400,000 ringgit. So the residual asset value S is equals to 2 over 3 over B. The B is initial value divided by the purchase value. So the resale value will be 1,600,000 and the asset HN is equals to 106 weeks, which is also known as 24 months and 2 years. Then next is I'm presenting about the total cost. So total of 7 types of cost we have faced in this project. First is material cost, which is 17,960,000. Second is detailed engineering cost, 5,400,000. Construction cost of 41,950,000. Labor cost of 4,320,000. Asset cost of 3,840,400. Heavy machinery and maintenance cost of 47,200 and other costs are 3 million. And the total cost that we have faced in this project is 76,517,600 ringgit. Finally, I'm going to present about the depreciation. So the total year that will be taken for this project will be total of 2 years. So total depreciation up to year for the first year is 533,333 ringgit, and the book value at the end of the year is 1,866,666 ringgit. And for the second year, the total depreciation up to 800,000, but the book value at the end of the year is 1,600,000.